Hi, everyone, and welcome back to Skill 8 of our Unit 7 notes, where we're going to be talking about vapor pressure and specifically relating it to Table H in our CRT. So just so you have it out in front of you, make sure you stop and get your CRT out now and turn it to Table H. In Table H, you will see a table that shows the boiling points of four different liquids at different vapor pressures. So it's really a curve that measures temperature versus the vapor pressure. So I put it in the notes here just so I could quickly flip back and forth to it. So here is an example of what the table H looks like, but it'll be much easier for you to look at this in your physical CRT that you have printed out in front of you rather than trying to do this on the screen here. So really, that's the best bet. Have it out in front of you on paper instead of trying to look at it on the screen. Okay, so let's start by just doing some basic review from our last part 1 of Skill 8, where we talked about the different relationships here. So in Table H, you should be aware of what the relationship is between the temperature and the vapor pressure. So in each of the curves, you should notice that it's a direct relationship, meaning that as the temperature increases, the vapor pressure also increases. So let me flip forward here and show you what I mean. So looking at any one of these four curves, we'll get to why there are four different curves in a moment, but for now, it doesn't matter which one you're talking about. As the temperature increases down here on the bottom, you will see that the curves all increase. And the reason they increase is because that vapor pressure should also increase. That is a direct relationship. And that's something that you should remember from the part 1 of this, where we talked about the fact that an increase of vapor pressure means that the substance is more likely to go into the gas phase, and we know that that is generally something that happens when we have higher temperatures. Okay, so then what else do we need to know? Well, we should know a little bit about the relationships between vapor pressure and intermolecular forces. So again, this is review from the last video that you watched, that vapor pressure, when it's low, it is low because it has strong intermolecular forces. If it's a high vapor pressure, that's because the intermolecular forces are very weak. So over here on the next page, I tried to write this in on this example of the CRT, or I'm sorry, on this example of the table H, just so you have it on the table H for you to reference. Anything that is closer to the top of the graph up here, it is at the top of the graph. These lines, as they reach the top of the graph, they reach the top of the graph because that's a higher vapor pressure. If it's at a higher vapor pressure, then that means it's easy to evaporate, and which means it has a weak intermolecular force. So all three of those things are related to each other, and we will compare that to things that are at the lower side of the graph down here. In the lower side of the graph, or at the bottom of any one of these four curves, it means that that substance has a stronger intermolecular force at these temperatures down here, that the vapor pressure is lower, and it's harder for these things to evaporate. So these 3 points are always going to be true when you're talking about a substance at the closer to the top of the graph, and these 3 points will always be true when you're talking about something at the bottom of the graph. Okay, so the next thing that you should know is what the dotted line on the graph means. Well, the dotted line on the graph means it's the standard atmospheric pressure, or 101.3 kilopascals. So looking at table H, you will see that the y-axis here has a vapor pressure given in units of kPa. So we're not using atmospheres here, but it doesn't matter. This vapor pressure at the line that I've highlighted here in pink is the standard atmospheric pressure, which is 101.3 kilopascals. That atmospheric pressure is also going to be where the normal, where the normal boiling point of the substance occurs. Okay. So When the vapor pressure of any substance equals the atmospheric pressure, that is what we say is a substance that's where the substance will boil. So in other words, the temperature where the curve touches that dotted line, that is the boiling point of that particular liquid. So let's look at what this means on table H on the next page here. So looking at this graph here, if I were to look at each of these four different lines, so the first line you'll see is labeled propanone. The next one is called ethanol, the third one is water, and the fourth one is ethanoic acid. So let's just start by looking at propanone. Well, propanone has crosses the dotted line at this spot right here. And if I take that spot and I follow it down to the curve right down here at the bottom, I should be able to determine what the boiling point of propanone is. So it's important to make sure that you're reading this graph correctly. So if this line is 50 right here, and this is 75 up here, then each of the lines in between are worth 5. So this is 55, 60, 65, 70, and then 75. So the boiling point of propanone is right at about 55, 56 degrees Celsius. But that mark right there is the boiling point. That's a different boiling point than something like ethanol. This is ethanol's boiling point. It's where the ethanol curve crosses that dotted line. It's a different temperature than for propanone. And same for water. Water's boiling point is up here. And then ethanoic's boiling point is the highest, being all the way up here. So let's go through this this graph here and try answering a few questions together and see how we all do. So which of the substances has the lowest boiling point? So I just marked the four different boiling points here. And again, if I just look at which one's the lowest, well, that should be pretty straightforward that this was propanone. Okay. So then what about the next question? Which of the substances has a boiling point at 100 degrees Celsius? So if it doesn't tell you anything about pressure, then we're going to assume for boiling point, it means where I'm crossing that dotted line. So if this is 100 and I follow that 100 line all the way up until I reach the atmospheric pressure line, then that makes sense that this is water. All right, so which of the substances has the highest boiling point? See if you can figure that one out. Okay, did you all pick ethanoic acid? Ethanoic acid's boiling point is all the way up here at about 118 degrees Celsius or so. All right, what about the next one? Which of the substances has the highest vapor pressure at 40 degrees Celsius? Okay, so this is a little bit of a different question. So first, let's pick where 40 degrees is. So here's 50, this is 45, and this is 40. So at 40 degrees Celsius, I'm going to follow the lines up and see which substance has the boiling point, or I'm sorry, has the vapor pressure highest. So that the curve that is highest is the propanone line. So it has the highest vapor pressure at that temperature. Okay, so can you figure out which of the substances will boil at this 79 degrees Celsius temperature? Okay, I hope you picked ethanol. Again, 79, here's approximately 79, and if you follow that line up, it hits the ethanol line. Okay, let's look at a few more. At what temperature will alcohol boil when the atmospheric pressure is 50 kPa? So this is a little bit of a different question. This question says alcohol, so just in case you're wondering, alcohol means ethanol. Okay, if the atmospheric pressure, instead of the atmospheric pressure being 101.3 kilopascals, what if the atmospheric pressure was 50 kilopascals then? So at this line right here. Then the question is, which temperature will that alcohol boil at? So I have to make sure I'm on my alcohol line. So this is the alcohol line right here. And I'm going to start at the 50 kPa pressure and follow it down to the bottom where the temperature is. And hopefully you're getting something like 62 degrees Celsius. Okay, so let's see if you can answer the rest of these questions on your own. I'll see you back in a few minutes. Okay, so hopefully you've gotten these answers. If you're having a hard time coming up with how to do this, make sure that you are carefully reading the graph. The biggest mistake that most people make is that they are trying to do this like on a digital screen instead of on a piece of paper. It's much harder to read this graph on a screen. The other thing that they struggle with is they are miscounting what each of the lines within the chart are representing. So each line or each part of the grid is representing 5 on the x-axis, and on the y-axis they're each representing 10. So 10, 20, 30, 40, 50. So it's each square means a different thing. Okay. So hopefully this is what you've received for your answers there. Okay, and then I'd like you to see how you do on the next page. So let's just try the top and I'm going to give you a chance to look at these 7 questions and answer them on your own. Okay, everybody, so these should be the correct answers. And if you're having a hard time getting these, then make sure you ask for some extra help. Okay. Lastly, you've got 5 more problems on the bottom of the page here. Let's see how you do on those. Okay, again, double check your work. Make sure that you understand what's going on. If you're struggling with any of these answers, you can absolutely send me a message on Remind or via email, and I will do my best to help you out. So hopefully that all makes sense and that the practice was helpful in making sure that you know how to use Table H. Okay, thanks so much. I'll see you next time.